Okay, so I hope all of you are following strict plan, because now we have second midterm going to happen within 2 weeks or something, right? So you should have, proper sleep and maybe at least 5 hours combination of everything, I guess, because I think sometime you don't know what to do, how to study and so on and so forth. But anyway, we are going to start, as you saw yesterday, yesterday that we have covered a couple of basic concepts quickly, right? Limit, continuity, differentiability. Today I am going to look at some more examples of differentiability, and then I am going to talk about Cauchy-Riemann equations, which is a very, very important thing. So Cauchy-Riemann equations involved relationship between the component functions u and v of a complex valued function. And then we will also introduce another interesting concept known as analytic function. Okay. So a function is analytic at a point z is equal to z0 if not only it is differentiable at z0, but also in every point in the neighborhood of z0, that circular disk. Okay. So that is much more powerful condition. And then we will see a couple of relationships and so on and so forth, right? And I hope. So also Cauchy-Riemann equation, there are two forms. One is xy coordinate, another one is polar coordinates. And so some examples we are going to do for that. Okay. So if a function is analytic at a point z is equal to z0, it is also differentiable at z is equal to z0 by definition, right? And if it is differentiable at z0, it is also continuous at z0, because differentiality always implies continuity at that point. But the reverse is not true. So if the function is continuous at a point z is equal to z0, it may not be differentiable at z is equal to z0. If a function is differentiable at z is equal to z0, it may not be analytic at z is equal to z0, right? So that reverse thing is not true. This is the whole summary of all this, what I am going to discuss. So as a t-time problem, give an example of a function, complex valued function, which is continuous at z equal to z0, but not differentiable at z is equal to z0. Continuous but not differentiable at z equal to z0. Similarly, the other question, give an example of a function which is differentiable at z is equal to z0, but not analytic at z equal to z0, right? So these some things. And by the way, I think I forgot our popular questions like, give an example of a complex valued function which is differentiable at 5 points. Right? Those things are always possible. Okay. Not differentiable at 4 points. Right? And differentiable everywhere on the finite plane, the complex plane. Right? So all these kind of questions you can, or give an example of a complex valued function which is continuous only at 10 points. All these kind of questions you can actually explore, say, a certain number of points. Okay. Now, by the way, I think some of you may be asking for books, which I think I should again, I have talked about these things in our third lecture probably, yes. Yeah, I guess third lecture. So I am going to, yeah. So Thomas calculus is of no use now, I guess you might have realized, so you can throw that out, right? So now what is left? This blue book by Jan Engel, right? Jan is not there. So this book contains all the material at one place, although I don't like the book, but everything is there at one place. Similarly, the second book by Cauchy. These are two popular books. Both are used extensively throughout India, and Cauchy is used outside also, for engineering students, okay? People who are trying to understand it. So, but sometimes they do not cover enough beauty, okay? So you will find that they are not up to the really very beautiful books, but yeah, if you have it, and if nothing else you understand, you just look at this book and everything should be fine if you read everything. Okay. So I'll just say that this is not required now. This book and this book, any of them is fine. So this is Indian authors from IIT Delhi, and Crazik is another very popular book, right? So these two books are enough, because you will find most of the material, whatever we are talking about, in these books. Now, if you want to go for some beauty, so there are a couple of beautiful things. So I think you see here, this was for classical, this was for classical. Some of the complex things are there, but you know, it's okay. So I think now you don't have to read up to this place. Some vector analysis you can find in this book. Advanced calculus you can find in this book is must. I would suggest this book by Sham, Outline Complex Variables by Spiegel and Lipschitz. This book has a lot of examples, which probably you will like. Okay, a lot of examples. So you can actually find a copy in library or whatever. Plenty of examples from, you know, beginning till end. And any good student will be able to finish this book in a week. एक हफ्ते से ज़्यादा नहीं लगेगा, इतनी आसान किताब है, right? Okay, but full of examples. And then we have some advanced level books, those who are super excited. Then there is this book by Cauchy, Churchill, Elfros, Titchmarsh. These are on complex. Okay, but this is also on complex, but you know, this is something, I mean, if you have read this book, everything in this course is covered here, so you don't have to go anywhere else. Okay, but if you really want to enjoy the beauty, then these 4 books are there in more depth and more bit advanced actually, but it's okay. Okay, I love this book, Titchmarsh, Theory of Functions, beautiful book. Okay, so that's all. There is also calculus of manifold for, you know, several variables, but I think this is also, Spivak is a very famous author. I think, you know, if you want, you can read it. And rest are differential equations, which we can talk about it later, right? Any question about the books now? So I think for complex, if you are able to get this hold of this book of Spiegel and Lipschitz, right? Sham's Outline of Complex Variables, you know, it's very easy to read, first of all, accessible at your level, and within a week you can finish the entire book. सुबह 4 बजे बैठ जाओ पढ़ने, 6 बजे तक पढ़ो, 2 घंटा रोज, and then you are done, right? So you will enjoy. I mean, that is because it has a lot of pictures, this and that, you know, nice book. Okay, so I hope now for books, you know, and the previous ones are, you know, some of them are involving complex also, but they are, you know, more bit beautiful books. Okay, then we'll talk about these the differential equation things later on. Okay. Yeah, but this, as I mentioned, these 2 books are also okay, although I don't like them. So you can see what kind of standard they have, but for engineering students it is okay. Okay, so and this book by, you know, on vector analysis, this is also important. These 2 books for some of the vector calculus. I mean, not everything is covered. We have not covered everything in that from that book, but you know, some concepts you will enjoy. Okay, so we were looking at this function f of z is equal to mod of z square, and we wanted to find out whether the function is differentiable or not, or if it is differentiable at what point. So if we call w is equal to f of z, then dw of dz is nothing but limit delta z tends to 0 delta w over delta z, right? Now whole thing is nothing but mod of z plus delta z whole square minus mod of z square divided by del z. Now we know that z into z bar is equal to mod of z square, right? This formula you know, right? If z is x plus iy, z bar is x minus iy, you multiply, you will get x square plus y square, which is basically mod of z whole square. So we can simplify this whole thing is z plus delta z, z bar plus delta z bar, bar, you know, you will have z plus delta z bar, you can separate bar inside, right? That is okay. Minus z into z bar divided by delta z. So whole thing is nothing but z bar plus delta z bar plus z into delta z bar over delta z. So we can simplify whole expression. Now I have to take limit of this as delta z approaches towards 0 to check whether the function is differentiable. If this limit exists for any z, for any arbitrary z, function is differentiable for any point on z, right? Now remember, f of z is equal to z square is differentiable everywhere, right? I mean, and the value is 2 times z, we saw yesterday, right? Here, what happens to this limit if you move along x-axis? So that means y is equal to 0, or that means, you know, all this delta y component will be. So I can just compute, right, everything, and you see that along x-axis what happens, along y-axis what happens, you know. 2 paths I am choosing and trying to see whether limit exists or not at all, right? So this is our, so I need to find limit of whole thing as delta z approaches to 0. Okay, so this is a dw over dz. Now what I do, now delta z is nothing but delta x comma delta y, right? And this approaches towards 0 comma 0 in any manner. It should approach to this in any manner if the limit exists, right? Now when delta z approaches towards 0, okay, through the points delta x comma 0, means y component is 0, then what will happen? So on the real axis basically, then what will happen? Delta z bar is equal to delta x plus I 0 bar, right? Because y component is 0. Now this is nothing but delta x, because delta x is real, right? So bar will be same thing as delta x minus I 0, okay, which is same thing as delta x plus I 0, which is nothing but delta z. So in this case, delta z bar is equal to delta z, right, along x-axis. So in this case, delta w over delta z will be what? So if you look at here, so delta z bar is equal to delta z. So this quantity will be 1, right? And I can just simplify this whole expression. When delta z is equal to delta z bar, okay, so we are going to get the following. Whole thing is nothing but z bar plus delta z bar plus z. Okay, so when we take now limit delta z tends towards 0, this value will be what? Z bar plus z. So along x-axis, this value limit of the value of the limit is z bar plus z. Similarly, you can compute along y-axis. So that that means when x is equal to 0. So when we are moving through, so when delta z approaches to 0 along 0 comma delta y on the imaginary axis, in that case delta z bar I can simplify is 0 plus I times delta y bar, nothing but minus of iy, because you see 0 plus iy is nothing but 0 minus iy, I can take minus common, right? So this is nothing but minus of delta z. So essentially along the x-axis delta z bar is equal to delta z, along y-axis delta z bar is equal to minus time delta z. So again I can simplify the expression, this expression here, I can simplify here, so you get the value. So in this case limit delta w over delta z will be z bar plus delta z bar minus z, and when you take the limit as delta z tends towards 0, this value will be what? Z bar minus z. So here we have one quantity and here we have another quantity. So along x-axis the value is z bar plus z for this limit, along y-axis the value is z bar minus z. Now do you think that the limit exists? हाँ? लग तो नहीं रहा है exist करेगी, लेकिन what you can do, at one point they are equal and that point is what? 0. 0 पे तो same ही होगा ना, so हो गया काम हमारा. If you compare to, you know, anyway, so that means this function, so limit, I mean this function should be differentiable only if z bar plus z is equal to z bar minus z, right? And they are equal only if z is equal to 0. Therefore, if limit exists, z bar plus z should be equal to z bar minus, z bar plus z is equal to z bar, z bar plus z is equal to z bar minus z. This implies that z is equal to 0 is okay. So f of z is equal to mod of z square seems to be is differentiable only at z is equal to 0. Now actually, if you only compute at z is equal to 0, delta w over delta z turns out to be delta z bar. So, you know, from these two limits I could guess that the limit should exist at z is equal to 0, but I need to show that. So I just again look at the limit delta, again look at this expression, and what will happen if z is equal to 0, right? So you are only left with delta z bar. So delta z bar is there, right? Now if you take the limit of whole thing as delta z approaches towards 0, this value is 0. So f dash of 0 is 0. Right. So thoda sa alag hai, right? The complex sense as compared to the real sense, you can see that slightly different things are there, right? Definitions are same, you just compute the limit and so on and so forth, right? And so if the limit exists, it should exist in any manner, right? The point here delta z should approach towards 0 in any direction, okay? So I have taken two directions, I saw what are the values and then I try to compute, right? And actually I can compute exactly at origin what happens, okay? So this is an example of a function which is differentiable only at one point, 0. So my favorite question. So this function is differentiable only at z is equal to 0. So this will give you some idea to construct functions which is differentiable only at 4 points, 5 points, right? This is only differentiable at 1 point. Also, if you look at f of z is equal to mod of z square, this is nothing but x square plus y square plus I times 0. So basically u of xy is x square plus y square and v of xy is 0. Now the component functions are continuous, right? These component functions are continuous as a function of two variables, right? Is still And actually partial derivative also exists. You can see that still the function is not differentiable. F of z is not differentiable. So there is some relationship between the component functions and the complex valued function. Okay. So what I am saying that u and v have continuous partial derivatives okay of all order, yet f of z is not differentiable. Right. Of all order at a point, yeah. I mean, at any point actually they are differentiable. The component functions are differentiable. I mean, the partial derivative exists at any point, but the corresponding f of z is not differentiable. It's only differentiable only at one point, z is equal to 0. But the function f of z is continuous. You can see that, right? F of z is continuous. And of course, the component functions are continuous, so f of z is continuous, okay? Okay, so I think now comes the most beautiful, by the way, some examples that I leave it for you to verify. Discuss the differentiability of the function f of z is equal to z bar. Question number 1, 2, f of z is equal to real part of z. 3, f of z is equal to imaginary part of z. Actually, the derivative will not exist for any point. So these functions are non-differentiable. Okay, so you need to prove it. I leave it up to you to prove this fact that any of these functions are not differentiable for any arbitrary z. So what you need to do, just compute the limit delta w over delta z, right, and see that the limit does not exist, right, for any z. And so these functions are non-differentiable. Got it? Okay, these are the easy functions. Now come most important thing, CR equations, or also known as Cauchy-Riemann equations. Okay. So f of z is given to you. F of z is equal to u plus iv. U is a function of two variables, v is a function of two variables. And suppose function f of z is differentiable at a point z is equal to z naught. Then there exists a relationship in terms of partial derivatives of the functions u and v. In fact, del u over del x is equal to something, in terms of v, and similarly the other things. So let me write down those equations. So suppose f of z is equal to uxy plus I times vxy, right? It's a complex valued function, so there are two component functions u and v. And suppose f dash of z exists at z is equal to z naught is equal to x naught plus I times y naught. Right, so at z is equal to z naught, the derivative exists. Then what happens? Then it says that first order partial derivatives of u and v must exist at x naught comma y naught, and they must satisfy, they satisfy del u over del x is equal to del v over del y del u over del x is equal to del v over del y, and del u over del y is equal to minus times del v over del x. These are the beautiful relations known as Cauchy-Riemann equations. If function is differentiable at a point z is equal to z naught, at that point these partial derivatives are equal. I will show you the proof, it's not very difficult. So differentiating u with respect to x partially is same thing as differentiating v with respect to y, and differentiating u with respect to y is same thing as negative of differentiation of v with respect to x. So this is a nice relationship, and it has many consequences actually. So in shorthand form we say that, I mean, ux is equal to vy and uy is equal to minus vx. Shorthand, right? You can write like this. Okay. Also, the value of the derivative can be written as ux plus I times vx. That's another important relationship. So what is given? Function is differentiable at a point z is equal to z naught, right? That means the limit delta z tends to 0, delta w over delta z exists, right, at the point z is equal to z naught. If f of z is of the form u plus iv, then they satisfy this relationship, these two relationships, and the derivative at z naught is given as ux plus I times vx. So if we compute ux plus I times vx, and then I can compute f dash of z at that point, right? This is a shorthand formula, right, for computing the derivative. Okay, so this is the whole scenario. I am going to give you a very quick proof. It's not very difficult, just you need to compute the limit, right? And then some consequences, let us see. So these derivatives are at the point x naught, y naught. I mean, this is something I forgot to mention. Okay. Okay. Okay, so let us see what can be done here. So proof is very simple. Now z naught is x naught plus I times y naught. So and delta z is delta x, delta z is delta x plus I times delta y. Change in w is equal to f of z naught plus delta z minus f of z naught. Okay. So this can be simplified to u x naught plus delta x comma y naught plus delta y minus u of x naught comma y naught plus I times v of x naught plus delta x y naught plus delta y minus v of x naught y naught. कितने लोगों को समझ में आया ये कैसे आया? It's very simple. I have just yeah, you got it right. F of z को u plus iv रख दिया and we expanded, right? और कुछ नहीं किया है. कॉमन टर्म्स को अलग ले लिया, राइट? सो रियल पार्ट को एक तरफ कर लिया, इमेजरी पार्ट को एक तरफ कर लिया, राइट? एक्सप्रेशन में रख करके रियल को अलग कर लिया, इमेजरी को अलग कर लिया, और कुछ नहीं. तो थोड़ा टाइम बचेगा, राइट? सो आई जस्ट स्किप दैट थिंग, राइट? सो वी हैव दिस क्वांटिटी. So basically u of x naught plus delta x comma y naught plus delta y plus I times v of x naught plus delta x comma y naught plus delta y is first term, right? Similarly the second term, right? Now suppose the limit exists right? So in that case, f dash of z will be at z naught actually, limit is basically real part of delta w over delta z plus I times limit delta x comma delta y goes to 0 comma 0 of imaginary part of delta w over delta z. If the limit exists, this thing, that means this should exist for the real part as well as imaginary part. I can look at it, right? So real part of this thing plus I times limit of imaginary part of this, right? And now when I say delta z is equal to going to 0 is same thing as delta x delta y going to 0 comma 0, because now we will look at the two variable function. So I have taken the limit to be delta x comma delta y goes towards 0 comma 0. Similarly the other side, and this should go in any manner, right? In any manner, right? From any path, right? Then limit should exist, right? It is given that the function is differentiable, so these limits exist, we know, right? And so this I should write down in any manner. This is important thing. Here also any manner. So if any manner, I can again say that along x-axis means when y is equal to 0, I can compute this value. So this is our main formula. I am going to use it. Okay. So here I am going to compute this limit along x-axis and along y-axis, right, and see what happens. Right. So when delta x comma delta y approaches towards 0 comma 0 along delta x comma 0, that is when we have delta y is equal to 0. So y axis, we are moving towards x axis, y is equal to 0 means delta y is equal to 0, nothing is there, right? So this limit will be delta w over delta z is equal to the whole expression will be x naught plus delta x comma y naught minus u of x naught comma y naught divided by delta x plus I times v of x naught plus delta x comma y naught minus v of x naught comma y naught divided by delta x. What I have done from this expression, from this expression actually, when we expand, I have just put delta y is equal to 0, right? So everything will be simplified. Okay. So basically this is okay. This is the whole thing. I can now look at real part of delta w over delta z as limit delta x comma delta y goes towards 0 comma 0. This thing is nothing but u of x naught plus delta x comma y naught minus again I can write down u of x naught plus delta x comma y naught minus u of x naught comma y naught divided by delta x. So this nothing but del u over del x evaluated at the point x naught comma y naught, right, by definition of the partial derivative. Similarly the other part, limit imaginary delta w over delta z when delta x comma delta y approaches towards 0 comma 0, right? So when delta y is equal to 0, so this is nothing but delta x tends to 0, v of x naught plus delta x comma y naught minus v of x naught comma y naught divided by delta x. This is nothing but v of x divided by x naught, I mean evaluated at x naught y naught. So del v over del x actually. Okay. So what we have done, we have taken the whole expression and then took the real part, we computed the real part along x-axis when delta y is equal to 0, similarly the other part. And now we have the two parts, I can combine them. So f dash of z naught is nothing but ux del u over del x evaluated at x naught comma y naught. अरे यार ux नहीं लिखने देगा ये, f dash of z naught equal to ux x naught comma y naught plus I times vx x naught comma y naught. So this is the formula. I times v of x, right? So del u over del x evaluated at x naught y naught plus I times del v over del x evaluated at x naught y naught is a f dash of z naught. But this is, only along one axis we have computed this value, right? Now I have to go and compute it for the other axis. So when del z approaches towards 0 through point 0 comma del y, so x component is 0, that is when del x is equal to 0. Whole thing will simplify. You can check that f dash of z naught turns out to be in a similar manner vy x naught comma y naught minus I times uy x naught comma y naught, or in other words this is minus I times uv x naught comma y naught plus I times vy x naught comma y naught. So what we have done, we have taken the definition, in a sense we took the definition of delta w over delta z when delta z approaches towards 0, we computed it along x-axis, computed it along y-axis, and then obviously if the limit exists, these two things should be equal, right? So we have two values, right? One is this, another one is this, right? They should be equal, and once they are equal, that gives you the condition. So conditions are del u over del x evaluated at x naught y naught is same thing as del v over del y evaluated at x naught y naught, and del u over del y evaluated at x naught y naught is equal to minus v of x, I mean x naught y naught. So del v over del x, right? So these are the Cauchy-Riemann equations. Okay. So the idea is very simple, just compute the value along two axes and then limit exists. I mean if it is differentiable, it is given that the function is differentiable. So that means these two limits should be same. So we get Cauchy-Riemann equations. Okay. थोड़ा lengthy हो गया, but it's some calculations, right? I mean it's not very difficult thing to understand. Okay, so एक example करते हैं. So I am just writing again Cauchy-Riemann equations. So ux is equal to vy and uy is equal to minus vx, right? Take an example, f of z is equal to z square is equal to x z square, which is same thing as x square minus y square plus I times 2xy. Can you verify whether this function is differentiable? Can you compute Cauchy-Riemann equations? So this is u, this is v. So del u over del x will be 2x and del v over del y will be 2x. See, they are equal. what I am saying that you need to verify these conditions. So u of x comma y, x square minus y square, v of x comma y is 2xy. You can check that del u over del x is equal to 2x is equal to del v over del y, right? And del u over del y is minus 2y is equal to minus del v over del x, right? So Cauchy-Riemann equations are satisfied, so actually we can compute the derivative as 2x plus I times 2y is equal to 2 times x plus iy equal to 2z, right? वो formula मैंने लगा दिया, right? So if the function is differentiable, Cauchy-Riemann equations are satisfied. Okay. If Cauchy-Riemann equations are satisfied, whether the function is differentiable or not, so these are necessary conditions, but not sufficient conditions. You need some more conditions before you can say that when the reverse is true. Okay. Got it? So I think you can do some more examples like this. Okay, I think now you check for this f of z is equal to mod of z square. Whether Cauchy-Riemann equations are satisfied, can you check on your own? So u is what? X square plus y square and v is 0, right? What happens if you compute? So basically so uxy is x square plus y square and v of xy is 0 here. Okay, if the function is differentiable, Cauchy-Riemann equation must hold, right? So as now if you compute Cauchy-Riemann equations, you see that del u over del x is what? 2x, right? And then this should be equal to 0 because of the condition, right? Because the other part is 0 anyway, right? And similarly, you will have 2y is equal to 0. So x is equal to 0, y is equal to 0, you will get automatically. So other than 0, other places Cauchy-Riemann equation does not satisfy, right? The function is only differentiable at origin. It is clear. So basically this shows that f dash of z does not exist at any non-zero point. Looks like, I mean, I would say that Cauchy-Riemann equations are not sufficient conditions. Since it looks like they are satisfied at origin, we need to still prove that the derivative exists at origin. And that is something, I mean, of course we have shown you, just now we have shown you, okay, but using Cauchy-Riemann equations, I am saying that if you check Cauchy-Riemann equations, they are only necessary conditions, they are not sufficient condition, okay. If the function is differentiable at a point z equal to z0, they will satisfy Cauchy-Riemann equations. If Cauchy-Riemann equations are satisfied, need not be the function is differentiable, okay. It requires some more conditions. So let me write down that result. And this result is important. f of z is u of x comma y plus I times v of x comma y defined throughout some epsilon neighborhood of a point z is equal to z0 x naught plus I times y naught. And suppose del u over del x and del v over del y exist everywhere in that neighborhood, some epsilon neighborhood. If now the condition is there, if del u over del x and del v over del y are continuous, these are continuous functions at x naught y naught and satisfy Cauchy-Riemann equation, CR equations, then f dash of z naught exists. So this satisfy, I mean Cauchy-Riemann equations satisfy at actually z naught, okay, or x naught y naught I am saying. So the partial derivative should be continuous, then reverse is true. Again, so I am just rephrasing. If the function f of z is differentiable at z is equal to z naught, Cauchy-Riemann equations are satisfied at that point. If Cauchy-Riemann equations merely satisfied, does not mean that the function is differentiable. If Cauchy-Riemann equations are satisfied and the partial derivatives are continuous, reverse is true. Okay, that is the bottom line. So a beautiful t-time problem comes. Give an example of a function for which Cauchy-Riemann equations are satisfied, but the function is not differentiable at that point. हो गया ना अच्छा क्वेश्चन बनाने के लिए, right? So you need to look at some sort of function for which partial derivative is not continuous. Right, so from there you can start. I am giving you a hint how to approach that thing.